Howdy, and congratulations on your recent acquisition of a KRISYS robot kit from Texas A&M University. Today we will be doing a general overview of what you should have received in that kit when you got it in the mail. First, you should have a battery pack, you should have a set of wheels, you should have a ball bearing to act as the front wheel of the robot, you should have a set of motor mounting hubs, a set of 2 motors, one L298 dual H-bridge motor driver. You should have a set of wheel mounting hubs, a set of hardware to mount everything to this square piece of expanded PVC, and this will be the body of your robot. A set of jumper wires. These may be different than the ones pictured here depending on which board of intelligence you're using. We will talk about that here in a little bit. A set of capacitors, a set of diodes, 1 transistor, 3 different types of through-hole resistors, 1 set of surface mount resistors, 2 sets of 2 different color surface mount LEDs, 1 set of 3 potentiometers, 1 set of op amps, a header pin to go on and this will all be soldered to this sensor board here, a set of pigtails, and a set of inductors. And this is one kit for one robot.
Now for some specifics of your KRISYS kit. You should have a set of 3 27 kilo ohm resistors in your through-hole set. These are color-coded to be red, purple, and orange. If you need help discovering what your color coding is, Google a resistor color code calculator, and those will be very beneficial in identifying what you need. The next type of through-hole resistor is the 1 kilo ohm resistor. This resistor has a color code of brown, black, and red. The third type of through-hole resistor is the 10 kilo ohm resistor. This one may be a little difficult to see, but its color code is brown, black, orange. One thing to worry about when creating your kit is to break your inductors. These inductors are 104 inductors that you can purchase from anywhere, such as Mouser. These inductors have very fine filament wire inside of the bundle. If you bend the soldering leads too sharply or too close to the bundle, you will break this filament. The ideal resistance when measuring across a multimeter should be about 230 to 250 ohms. One more thing to worry about is your LEDs. These are polar elements, so they need to be put in your sensor board the correct way. You should have a set of 4 green LEDs and 3 red LEDs. When soldering your surface mount LEDs, be aware that they are polar, meaning they have to be soldered in the correct direction. Instructions on how to do this are attached in the assembly manual of your KRISYS kit. There will also be a tutorial on how to solder these surface mount elements.
You may find while constructing your KRISYS robot kit that you need a few additional items, and we wanted to show a few of them. This is not an exhaustive list, but here are a few things you may find you need while constructing your KRISYS robot. Here we have some wire. This is 24 gauge. It could be any color you like. Here's red and here's black for us. This is used to go from your motor terminals to your motor driver. We have here some jeweler screwdrivers. These are important for accessing the terminals on the H-bridge. A regular screwdriver won't fit down in there, so you do need a small screwdriver for that. We have a nut driver that's used for the nuts in your hardware pack for mounting things to the expanded PVC board. We have some diagonal cutters for cutting the leads off of the bottom of components. Once you've soldered them into the board, you'll have some left over. You might want to cut that off. We have some wire strippers for, well, stripping wire. And then we have here a soldering iron, and we will go over all of the things you need for soldering surface mount and through hole in our soldering tutorial video. The KRISYS robot is entirely customizable to the builder's desires. You can see this person chose to go with a hexagonal shape while this person went with a more triangular shape. So you can kind of do whatever you want as far as the shape and construction depending on what tools are available to you. But here are just 2 examples of how 2 different people approached the same idea. But you kind of see the same thing going on where the sensor board is in the front and you have the motor driver in the back with the motors in the back, and the ball bearing there at the front as the front wheel.
There are different control options that you have for your KRISYS robot. For example, This robot uses a BASIS FPGA board. Currently, the Texas A&M University class that uses the KRISYS robot uses the BASIS 3 board. Another option you may have is using an Arduino or a TI launchpad, as seen on the other robot. This launchpad is actually the CC3200 launchpad. You can use any board you want when constructing your KRISYS robot, from an Arduino to a Raspberry Pi, or even the new BeagleBone. Worth noting is each robot you build may have a different control software. The BASIS boards run off of FPGA HDL coding or digital logic circuitry. The launchpad runs off of C++ through a terminal called Energia. The BeagleBoard or Raspberry Pi currently does not have any code built for it. You have to build code for that yourself.